Very good evening, ma'am.
I am Dr. Gurjeet from Chandigarh, postgraduate government college from Sector 11, Chandigarh. I am associate professor in chemistry. My area of specialization is organochalcogenides, which is one of the branch of inorganic chemistry.
Very good evening, ma'am.
Yeah, good evening. Are you hearing me?
I am Dr. Gurjeet.
Yeah. Hello.
Yes, ma'am. Yes, ma'am. Please continue, ma'am.
Yeah, I'm associate professor in postgraduate government college for girls, Sector 11, Chandigarh. I'm associate professor of chemistry, and my area of specialization is organochalcogenides, which is sub-branch of inorganic chemistry.
So nice of you, ma'am. So nice.
Thank you. Thank you.
And meet our Guru, Professor S. Srinivasa Rao, sir. Sir is also from chemistry background from USC, ma'am.
Okay. Okay. Thank you.
Sir, now our session is on YouTube live streaming also. I had posted the link in chat box, and I'm posting the same in the group also, sir. Our WhatsApp group is there, and I'll be sending to all the guests and participants also, sir, through WhatsApp now. And with the permission of Srinivasa Rao, sir, shall we start the session, sir, with a small introduction of our Sidvi Foundation, and afterwards today's speaker's introduction. Shall we start, sir?
Yes, before that, no, I'm just interfering. So one Mr. J.V. Rao has come online.
Yeah,
good evening. He is one of my colleague. He is a IIT Madras candidate, and he is an expert in project management. Actually, he is running one organization also.
Surya, thank you for introduction of me.
Since
we both studied together, myself and Surya Narayana in SV University. I did my mechanical engineering. I worked in SR Steel for around 20-25 years. Various fields, starting from the projects, operation, maintenance, and these engineering activities. So right now, I'm practicing project management from Hyderabad. I have my own consultancy. With this, I'm doing this project management consultancy and project management training. PMP prep course requires around 35 hours of training on the project management knowledge areas, which is approved by the PMI. So that's I've been doing it for the last 1 year.
Yeah.
This is my brief introduction about me. Thank you for inviting me for this conference.
Since we are starting not at 7:37, I just let us finish the introduction, because this is how you guys get together. And if there is some interest between yourselves with your backgrounds, you can continue later on this opportunity of meeting each other. So that's why there are people that I can see 3, 4 have not introduced themselves. Please introduce yourself, what you are, and what your background is. So that will be helpful for you, and others will know what you are. Or at least you can say, like the other gentleman said, he's a program management. So people who are interested in program management may try to interact with him. That is this, how one has to build your bridges.
Yeah, good evening to one and all, and good evening to Sidvi Foundation. Myself, Mr. Shivaganesh, and I am working in 2 into 520 megawatt coal-based thermal power plant in Visakhapatnam. And through this lecture, I am interested to see the opportunities that renewable energy sources will plays a vital role or not in the future, like solar or wind? Thank you.
Thank you so much, sir. Siddhi Foundation also operating from Visakhapatnam only. I hope we can meet very soon, because you are also staying at Visakhapatnam. So to make some collaborative and innovative things which are useful for both Siddhi Foundation and its activities towards the societal benefits, sir. This is Dr. Aruna, sir.
Yeah, thank you, ma'am.
Thank you so much. Thank you. I request anybody else wish to interact with the auspicious gathering here. Okay. So not to make more waiting of our speaker, today's speaker, Professor S. Srinivasa Rao sir, and other stalwarts whomever joined over here. Actually, we had scheduled this program 7:30 to 9:30 every day. That means including half an hour before and half an hour after. And the session talk will be 1 hour exactly, 7:30 to 8:30. And 8:30 to 9 will be the interaction with the speaker. And afterwards, any interaction over the gathering will be one more half an hour. So this is the schedule, a detailed schedule of all these 7 days FDP program. So on this juncture, I wish to say a few words regarding the Siddhi Foundation. So actually, Siddhi Foundation is a multidimensional and multidisciplinary innovative platform which has been organized to give a chance to meet all the stalwarts, just like this gathering. So in this aspect, Siddhi Foundation usually organizing seminars, conferences, FDPs, and lecture series like this every month. And along with these programs, the Siddhi Foundation is aiming to recognize the services of both academia and researchers in terms of giving awards. So every international conference, we are making an award ceremony also. And Siddhi Foundation is aiming to organize such conferences, such gatherings on special days of Indian calendar, like say suppose national, like International Environment Day or National Ekta Divas. So in the month of October, we are about to organize one more conference. And this Independence Day, August 15th. So basing on that, we had planned the lecture series, 7-day lecture series. So likewise, every month, whichever the national day will come, an important day will come, Siddhi Foundation is organizing one conference. And I can say proudly that we are getting huge response from all over India and abroad also. We are getting not less than 70 to 80 abstracts for every conference, out of which we are accepting about 50 presentations. And I'm getting some good feedback from my guru, Professor Srinivasa Rao sir, and others also, the stalwarts of Siddhi Foundation. And one more milestone Siddhi Foundation crossed, that it has been registered as MSME and it got ISO also. And afterwards, we had started a professional body, Siddhi Society for Research and Development, that has been registered under the government of Telangana, and that is operating from Hyderabad. And a team of members, 7-membered professional body, and we are giving the professional memberships also for the students, scholars, and faculty also, which can enhance some of the API score for them. And by the grace of my guru, Srinivasa Rao sir's encouragement, we had started one international journal also, named as International Journal of Science, Engineering, Arts and Management, IJSCAM. And recently we got ISSN number also for that international journal. And one more milestone we are about to make, that is a SIDBI Society for Science and Technology, SIDBI Academy of Science and Technology, just like AP Academy of Sciences, like that. SIDBI also aiming to start SIDBI Academy of Science and Technology, clubbing both the Telugu states, Andhra and Telangana. So this is a small introduction regarding the SIDBI Foundation, and not taking much time, I wish to move upon the introduction of today's speaker, Professor Srinivas Rao sir. With the permission of Srinivas Rao sir, sir, shall I move upon to the session, sir?
I have no problem, but because you said 7:30, you mentioned others, so probably they may be coming or not, I don't know. So are you going to?
I'll be, actually I had informed in group also, sir. So somebody has joined and somebody about to join, sir.
Okay.
Yes.
So just I have no problem, but if you want to elaborate about SIDBI, I mean, I'm just to kill the time, I'm just talking. Or there are people who have not introduced themselves. This is the time they can introduce yourselves, or else we will just have talk and then afterwards we'll go away. So I'm just, generally I see more around 20-25 people coming in, but so maybe they are thinking it is at 7:30, so that's why I'm just telling. I thought Dr. Govind Reddy, Dr. Vijay, Mr. Arvind, ABC, I don't know what is American Broadcasting Corporation. Please introduce yourself, at least you will know, and if possible, show your face on video so that everybody can have some idea about who you are. Thank you. Somebody please start and introduce yourself, those people who have not introduced to the group. Okay?
Yes, I request Govind Reddy, sir. Could you please speak a few words, sir, by introduction of yourself to the gathering? Sir, you are in mute condition, sir. Please unmute yourself.
Okay, madam. This is Dr. Govind Reddy from Hyderabad. So I have retired from Indian Council of Agriculture Research, Government of India, after completing 35 years of service. After that, I have joined as Associate Dean in Greenfields Institute of Agriculture Research and Management, that is under Singhania University, Rajasthan. Recently, if you look at Outlook magazine, my Singhania University ranked 8th position under private universities at the level of India. It ranked 8th. So recently I have submitted my pre-thesis. Submission I have completed, I have presented. So leftover only Viva is leftover, madam. So this is my self-introduction. I have been much impressed by SIDBI Foundation and its activities. And also, I am very much impressed by the lectures previously given by eminent professionals. So, I am very happy to join in this 7-day program, madam. This is my introduction. Thank you, madam. Thank you for accepting my this thing. So, this is my introduction, madam. Thank you, madam. Thank you, and good evening to one and all. Thank you to one and all.
Thank you so much, sir. Thank you.
Thank you,
And
madam.
first, Jinal Patel. Arvind Kumar, sir.
Good evening, madam.
Good evening, sir.
Good evening, madam. I'm Arvind. I'm working in Sri Hindu College in Hyderabad in mechanical engineering specialization, madam. So I'm very much eager to participate in the lectures given by so many lecturers.
Thank you so much, sir. Thank you. And I request Dr. Soundari, ma'am. Dr. Madhu Sharma, ma'am.
Good evening, ma'am.
Good evening, ma'am. How are you, ma'am?
I'm good. Good evening, all of you. I'm Dr. Madhu Sharma from Chinmay Degree College, Haridwar. I congratulate ma'am for successfully organizing all the conferences and seminars, and I wish you all the best for this lecture series also. So, thank you, ma'am.
Thank you so much, ma'am. Thank you. Thank you for your warm wishes to Sidvi Foundation, ma'am. Thank you. And I request Professor C.H. Vijaya, ma'am. And anybody else, please? Deborah, ma'am.
Yes, ma'am. So every time when I participate this, it's upgrading my knowledge, ma'am. And I gather so many information, and it also helps me in carrying out my research work also, ma'am. So as a part of education, and this is helpful to me to upgrade my knowledge, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Thank you so much. And it's my pleasure, ma'am, to have all of you. And I request you, Deborah, ma'am, please introduce yourself with your affiliation also to the gathering, ma'am, and your work area also, ma'am.
Yes, ma'am. I am Dr. Deborah Paripurnam, and I am assistant professor in the Department of Biochemistry in Nada Saraswati College, Theni, which is affiliated to the Mother Teresa University, Kodaikanal. And I'm doing I have completed my PhD, and I'm also motivating the students to do the research work, as I'm guiding the MSc students as well as the MPhil students. And I'm always gathering knowledge is very important in this science field as well as in the life science department. So this life science department is comprising of all the 10 units, that is from microbiology as well as from physics, chemistry, everything. So yeah, as whatever conference you are conducting, ma'am, it is helpful for me. I am getting some points from that. So I'm thankful to you, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Thank you so much. I request Dr. Rajeshwari, ma'am, from Kalaburgi.
Am I audible, madam?
Yes, ma'am.
Okay. Good evening, everyone. I'm Dr. Rajeshwari. I'm assistant professor in the Department of Life Sciences, and I really feel privileged to be part of this session, Think Beyond lecture series. I resonate a lot with this theme, that is Think Beyond. Basically, my academic and research interests revolve around sustainable functional foods, agri-waste valorization, and holistic wellness. What excites me the most is how knowledge can be applied in our laboratories and our day-to-day life, and also in the classrooms, basically. So the theme of Think Beyond resonates very much deeply with me, because the true progress often comes when we step into out of our comfort zones and challenge the old patterns and bring together science, values, and human well-being. I sincerely thank Siddhi Foundation for this wonderful opportunity, and I look forward for engaging sessions with for this inspiring initiative. Thank you, madam. Thank you, Professor Srinivas Rao, sir, and thank you, Aruna, madam, for this wonderful opportunity.
Thank you, ma'am. Thank you so much. And we are about to have your one of your session also in all these 7 days, ma'am. Thank you so
Yes,
much.
madam. Very much excited for that, madam. Thank you, madam. Thank you so much.
Let me take the privilege of adding 1 or 2 lines, extend Dr. Rajeshwari's brief saying. At the present meeting, the way 1 week workshop or lecture series is actually framed on the basis that everybody will have a taste from what different faculties provide to the society. Just to give a flavor, we don't want to go into detail. I mean, unfortunately, I start my talk, it's a little bit more technical in chemistry area. The next to talk something is related to the program management, how higher officials in the management structure look at the operational sequence of an industry, or how they plan, to give you guys a little bit of flavor, because they have to make a balance between the workers, the company, and also the stakeholders. So that is how we designed that talk. The third one is in the area of life sciences, how mind works, how the neurons will work. If we are augmented the process where we give support to the brain to look at any particular thing in a 2 or 3 directions, how it will be clear for the mind to register and respond. So that's how we felt it was a very wonderful flavor for this one. The other talk we have selected in the area of medical science, how the transplant surgery, how transplant, what is the importance, and also the ethics, and what is good for people, or at least to involve people into the area of organ donation. That's a flavor. He's a famous surgeon from England will be talking about. So that's how we selected from that medical science. The next one is, I mean, the sequence may be wrong. I don't remember. I forget. We selected is on the environmental aspect of the system. So and also another talk is general about education, awareness, society versus education. So this is how we have formulated. I think a standby talk is on intellectual property rights. So if you are not going to have only one faculty represented in this 1 week talk. So please encourage and please enjoy yourself, and also ask questions. And if you guys think you have to digest and then you can ask, means on the last day, we may extend, allocate maybe 45 minutes after the talk to have any questions. They can ask any of the presenters. So they will try to answer it. And another thing is, should we really would like to have your input? How is it? How do you rate a talk? In fact, at the end of my talk, you guys can send an email how I did. It's simply a waste of your time or waste of my time. Or maybe I'm very shallow. I don't know what I'm talking about. How good it is, how it can be improved. One time somebody gave a comment. In my slides, I never showed any comic strips. Yeah, that's fair enough. I mean, that particular person is used to that one, and I am not used to. So, so without any hesitation, please give us your sincere comments, which should make sense. Or if you want further clarification of discussion, you can ask. So every day, please provide Dr. Aruna your comments on the talk, or what your expectations. So this is my, I took a privilege of adding a couple more words. Thank you very much. On this one, any questions you can ask before she is going to start the regular program.
I request anyone from the gathering, please respond to the sir's views.
Madam, what should be the duration of the presentation in this gathering? How many is it? How many minutes I can say?
Sir, actually, we had a plan to
నేను
give
ఇక్కడికి వచ్చి మీరే నా దగ్గరికి వచ్చింది
one session per day, sir. It is about 1 hour, and half an hour will be the interaction with the speaker, sir.
Okay.
On the same day. That is 7:30 to 8:30 will be the talk, and 8:30 to 9 will be the interaction. I request somebody please mute.
Okay, I can take up for this project management, PMO and project management and portfolio management. On that, I can give you a topic, and maybe 1 hour session I can give it to give you some introduction about what is project management, what is project, all this that sir said that you should give you a flavor only. That's I can give it in 1 hour briefly, but but my timings maybe slightly, because in the evening I'll be busy with some other classes. Today is not there. From tomorrow onwards, I'm going to have some online. Generally, I conduct online classes to the students.
Okay, well, I don't see your name, but while that is what it is, maybe you can talk to Siddhi Foundation for future type of things. At this moment, I forgot to tell one thing.
Yeah.
Basically, all these speakers, today's speakers, are this is a special lecture series. So that's why only one lecture, that is 1 hour full. And most of these the speakers which are being scheduled now in this series, I think it is for if I am correct, please correct me, Sarvepalli Radhakrishna Guru, this one, is it? Is it connected to that one? Something, it's a special significant thing. So almost all these speakers, either they have already received Siddhi Foundation Lifetime Achievement Award, which is the highest decided by the management, No, there is no application or anything. Or people who received distinguished career in their faculties, whether it is life science or engineering or whatever it is. And or who have great potential. We identified them
Okay.
with having a high potential. Only those people are giving a talk. That means you can say all these 7. Unfortunately, we have only 7 days a week. If it is 8, we have said Ashtadhiggajas. So these are the 7 gems you can talk about. So later on, if there is an interest, I mean, you can recommend. Yeah, we like this sort of in future also. So this is it's not like a conference where number of papers will be there and all. These are only a special. It's not the question of saying because I'm speaking today, it is special. No, this is what SIDBI decided.
Okay.
Okay. So
Fine.
you can, in fact, that's where what your input is important. You can actually add this one. I told you at the end you can submit to Aruna your inputs. In that one you can suggest. Yes, listen, madam, I am so and so. I have so much experience. I have done so many things. I would be more than happy to give a talk on project management. So all those things will be seriously considered.
Okay.
You understand? So
Yeah,
this time
I got it, sir.
With the addition of sir's sayings, I also wish to add one thing, sir. We can have exclusive sessions also, sir. So if you're interested.
In fact, let me tell you, this morning I'm feeling dizzy. Even now, I don't know, in the middle of the talk, I may not be able to talk. I have some imbalance problem. Then I told already somebody should talk if I cannot. So basically such thing happen. But in this sort of exercise or whatever it is, then afterwards I thought people may be interested in my talk. That's the reason I cannot avoid it. So if you guys in your feedback, your interests, your expertise, because we don't know. That's why I requested everybody, please introduce yourselves so that it could be a good mix. Or this is an opportunity to interact. I mean, I'm glad you came out and asked, suggested this. So that I'm saying you would please put it as a, I told you, feedback to Dr. Aruna. So everything will be considered. Okay? Because at the end of the day, what we want is science to be distributed to the whole spectrum of people. I mean, I'm just telling, I started as a chemist. Then I became a chemical engineer, a metallurgist. Then afterwards, I published in the several areas. In fact, I published in medicine, published in so many things. So this is only by integrating. That means once you can pool, you bring your senses together. Whether it is an electrical engineering, can be applied to biomedical research. So it is basically that is the reason, the idea behind formulating this sort of special talks. So please, everybody, please provide your feedback. Then only we can become better. We can make it better for us because we want participation. And also, when we say potential for, you could be next time when we see your extraordinary quality. I don't know yours. We may say, well, the committee may recommend you for the selection committee for a distinguished career. We don't know. Because as such, I can see you, you can see me. You don't know me, I don't know you. You understand? It is only by exchange of information we can get. And people who actually achieve the status of distinguished career or lifetime achievement awardee, please also it's a little bit Everybody has to pay for it. A memento will be your life memory. That means you just to put it. In fact, I'm telling you one thing. One time, although with all my experience, I applied for chartered engineer status in the United Kingdom, in England. It's a big process. At the end, there will be an interview also. So those got two or three who are already chartered engineers, they were talking to me virtual. Then they said, how do you feel? I said, basically, I never realized that I did so much. I used to think I have done nothing. I mean, still I can do. There are two issues. In fact, when I was being invited for the nomination committee of the Nobel Prize equivalent of the Japanese prize, the moment I said that, I slipped my tongue casual. Those three gentlemen stood up. He said, "Oh my God, you are in that committee." So we are immediately, there is meaningless to ask for an interview and all. So like that one, if we know the capabilities. So this memento represents, did I see this? And then it becomes, you become a role model, not as a person. Your memento is a showcase for your grandchildren. Oh my God, my grandfather did this, accomplished. I should be like him. So this is a word of advice I was given by one eminent scientist in agriculture. So I just passed on. So please provide your feedback and what you expect and what you want. I request now Aruna to start the program. I think it is exactly in my time, it's 10 o'clock. That means 7:30 your time. Thank you.
Yes. Thank you so much, sir. Before starting up of today's event and to the continuation of this discussion, I request J.V. Rao, sir, let us connect on this juncture, sir, after this session. And if not, tomorrow morning also, sir. If possible, please give me a WhatsApp message, which I have given you personally in this chat box. My number is there. Please give me a WhatsApp message.
Yeah, sure, ma'am. I'll give.
Thank you, sir. Thank you so much. And I take this opportunity to welcome all the auspicious gathering of today's event, Think Beyond. What exactly Sir said is 100% suits to this particular event. We had have a thought to think beyond, out of the box. That is the main motto behind constitution of this SIDBI Foundation also. As I myself belonging to chemistry stream, even though my profession is teaching, but my passion is joining hands together to explore the knowledge, to share the knowledge over the nations and the society for its beneficiary. So on this auspicious occasion, I'm very much fortunate enough to have such a stalwarts and in every of our event, such a wonderful persons are joining with us to explore their knowledge, to share their knowledge to the gathering. So this Think Beyond 7-day international lecture series also in the same manner, it is also started, and it's a very good beginning. That very healthy and fruitful discussion also we got some time for having this exploration. So, and I take this opportunity to welcome all the guests and participants, speakers of this 7-day international lecture series, Think Beyond. On this auspicious occasion, our today's first speaker, my guru, Professor Dr. Appajosla Srinivas Rao, sir. And it's my privilege to introduce him to the gathering. Sir hails from Chirala in AP, and sir received MSc in Chemistry from SV University and PhD in Applied Chemistry from Indian School of Mines, Dhanbad, India, and PhD in Metallurgy and Material Engineering from England, and MS in Engineering Management from George Washington University. And Dr. Rao sir is retired from his long tenure of service both in research institutions and at the universities. And he has published a few hundred of research papers and government reports also. And sir received nearly 50 awards, including Sidvi Foundation Lifetime Achievement Award. And it's one more honor to Sidvi Foundation and one more opportunity to Sidvi Foundation that I can say proudly, sir is the first Lifetime Achievement Awardee of Sidvi Foundation. And it's my privilege and my fortunate also. I'm fortunate enough to honor such a wonderful personality on this auspicious occasion. And sir lives with his wife Padmavati, ma'am, and sir is having two daughters, Dr. Sarada, MD in General Surgery with specialty in trauma surgery, and Dr. Yashodhara, PhD in Materials Engineering. All the family members, along with ma'am, also living at Bethesda, Maryland, USA. Thank you so much, sir. We are fortunate enough to have you, sir, as a first speaker of this auspicious 7-day lecture series. Thank you, sir. Over to you, sir.
Thank you all. It's my pleasure to be here today and talk about, in fact, giving the first talk on the 7-day lecture series. And can I share, could you play my
Yes.
presentation, please?
Yes, sir. I'm sharing the screen, sir.
Yeah, sure.
Please let me know whether my screen is visible.
And we can see, okay, now we can see your screen. Yeah. Yes, okay, that's great. So today I'm going to talk about synthesis and surface property evaluation of non-oxide inorganic materials or non-oxide ceramic materials, because non-oxides are generally ceramic, called as ceramic materials. In this one, I start with a simple thing, how a scientist rewrite and also look into that one. That is the first aspect. A lot of times we do things traditionally for ages, but now we are reinventing the wheel. That is the synthesis part of it. I will tell, it looks bombastic, synthesis process and all, what it is. I will just, it will give you a big smile also. The surface property evaluation. This one means a fight between, just hold on. The fight between an engineer and a scientist. How an engineer looks at it, if it is titanium diboride coating or silicon nitride or boron carbide. It's non-oxide, it's not, there is no oxygen. So engineer looks at it, yes, so they are non-oxides. Whereas a scientist, when he looks at it, he is not bothered about the bulk property. He looks at it, the surface, few monolayers on the surface. How the monolayers really respond. Are they really boron nitride or titanium diboride, silicon nitride, or are they being oxidized? So that is, so he is concerned with the few monolayers. So that is a fight between the scientist and an engineer. That is how they look at it. That is what I'm going to talk about in this one. Next slide, please. Generally, the high temperature ceramic materials, they're used as a coating on turbine blades, rocket motors, structural components, electronic and optical components. When I say structural rocket motors, let me tell you, I did a lot of work on it. When the rocket motor ignition takes place, in the first 2 or 3 seconds, the thrust will be so high, the rocket motor orifice means small where it will come out, the jet flow, it immediately becomes 2 to 3 times. So the moment the volume increases, the pressure drops down. So that's the engineering key issue to maintain that thrust to take off. So there are a lot of materials you used. I worked on rhenium coatings. That means the general rocket motors are made out of graphite because they have to maintain that heat. And then at the orifice, we put few monolayers, not very thick, because we need only for just a few instances. A rhenium coating. How do you deposit rhenium? So that was my research I have done on that one. So that is where the turbine blades in almost all the jet planes, the turbines are made out of titanium vanes. And then the vanes will be coated maybe about 10 to 100 microns thick. Ceramic, titanium, carbide, boride, whatever it is, zirconium, carbide. So these things will protect the integrity and the strength of the material at high temperatures. So that is how it is. Generally, what happens is, if it is on oxides, they can be done with simple chemical co-precipitation, hydrothermal, and all those things. Whereas these non-oxides are done at high temperature. They cannot be done at low temperatures. So it is called high temperature synthesis process. Next, please. What is this high temperature synthesis process? To be blunt with you, we are doing it every year on Diwali day. Knowingly or unknowingly, we lit the crackers, the sparklers. The sparkler, you just put it in the flame, and once it triggers, you just take out, and then you will see beautiful sparklings coming. And at the end, you just throw it away. It will not require any other heat. This is exactly what we are doing here. See, this we have been doing traditionally for thousands of years, but we are reinventing the wheel and calling it a different way in a bombastic terms, self-propagating, because once you light it, it continues. That is how you see in Diwali sparkles. So they are called self-propagating high temperature combustion synthesis. And very nicely, SHS. Can anything be formed? No. Certain reactions, when initiated during the chemical combination, heat is released. And if that heat can be utilized smartly, then what happens is it will propagate the next level of combustion. So that it was basically what it is. Here is an example. Nickel powder and aluminum powder, if we heat it to a high temperature, suddenly what happens is it forms a nickel aluminide with release of heat. And that released heat will continue sometimes what happens is if the heat is not reached to that level, secondary forms may also form. But if the sustained heat is very high, the secondary form will not form. That is basically what it is. Next, please. When you see the figures, you will know that one. See, what happens is you take a material and then what happens is you will heat it so that any entrapped internal gas bubbles will be gone and all. And then material gets heated. And suddenly, once it reaches to that high temperature where the reaction starts, it will continuously go to the end. In this case, I said if it is one monolayer, what happens? The reaction takes place, heat is released, and then come back. That means it terminates. So there is no terminate, nothing is required to terminate once it initiates. Next, please. And in for everything, thermodynamics will dictate the term. In the case of titanium and boron powders, the heat of formation is about the negative, higher the negative is more stable. It's very good. I mean, the delta G, free energy, is heat minus the fugacity times temperature. So you can actually, what happens in adiabatic consumption. So we have selected all these combinations, and we did that. We did a sparkler game with all to form all those things. Boron plus carbon, boron carbide, molybdenum plus silicon, molybdenum silicide. This molybdenum silicide is used as a furnace fuel heating element. Once you trigger, it will maintain very high heat, 2200 degrees. You can actually maintain that. So like that one. Good. Next, please. The way we do in this combustion synthesis is in 3 different stages. First stage, what you want to make. You bring them together and homogenize it, mix it. And that is what is called homogenization or mixing of the elements, elemental powders or whatever it is. Yeah. And the second stage is making a sample. That means to do it by making a pellet of that material. So that is what is called dry pressed. Because the reason we use dry pressed means there are so many methods. But here, in this case, we want only dry pressed. Just press, like a tablet, you just press it. And the third one is only on the surface, first monolayer, you ignite it. If suddenly whole thing ignites, it explodes. But only try to see only the top layer will reach that temperature of the chemical reaction. Then heat is liberated. You don't need that heating source. It will continue. Next, please. So in the case of then once synthesis is done, as I said, it's a argument between engineers and scientists. What is what? Having taken 2 hats, I have a reasonable understanding of how engineer and scientist they differ in their ideas. So for the scientific part of it, it is the surface chemistry that plays a role. Only he is bothered with the surface. Whereas an engineer, bulk property, you make a component and how it works, that is his requirement. So in the case of non-oxides, there is one metallic component and another will be a non-metallic. Or sometimes it could both could be metals. But generally the surface is invariably oxidized. The present study, I talk in detail on molybdenum disilicide. And also, I just go and show you the borides, how the surface chemistry of borides change. In fact, people who are interested in zeta potential, which is a surface charge. That is what I intended to pass on the message. That's why I took a very complicated system. Because I promised somebody to give a talk at their university on the zeta potentials at some other time. So I just skipped. These will be included there also because these are highly complicated systems. Next, please. So generally, how we characterize the surface is basically when an oxide surface is in contact with a polarizable media, that means water. What happens is it develops a surface charge. The reason being by taking a OH radical and losing a proton, it may become an acidic oxide on the right side. Or take a proton and becomes a basic oxide, which is OH2+, which is basic oxide. But there is a certain time or place where there is no charge, and that is called the point of zero charge. That's where it becomes only OH. Calcium oxide plus water, calcium hydroxide. It stays as calcium hydroxide at that particular condition. Or else it will take a hydronium ion and then becomes OH2+, which is a positive, negative, and also negative surface. Positive surface, negative surface. Generally, what happens is, if you take, I'm not going to the physics of it, potential energy diagram, attraction and repulsion together. If you write that from combination, it is actually rectangular hyperbola. It starts high, then goes. It is very difficult to find out the surface potential or surface charge, but some distance from the surface, which is typical of every oxide, we can measure it, and that is called the zeta potential. So that is how we measure the zeta potential. So zeta potential is absolute representation of the surface charge. Next, please. Next, please. So in the present study, I go detail into molybdenum. Moly means, I am using our technical molybdenum disilicide. And in boron, titanium boride, titanium carbide, aluminum nitride, and the powder synthesis is by self-propagating high-temperature combustion synthesis. That means Diwali fire sparkler method. And we did this characterization of the surface by what is called electrophoresis or electrokinetic method. And we used XPS to find out the surface species. We used diffuse reflectance, Fourier transformation, FTIR, and other thermal gravimetry and X-ray diffraction, etc. Next, please. Basically, what we did was, in these reactions, you need external heating. So we put this pellet, and then on the surface, just the surface, few more layers, to reach a very high temperature. So that means we apply a very high current, almost like a zapping. So once the reaction starts, the external heating is removed, switched off, so it progresses. So the reaction on the top is the reaction product and the reactants on the bottom. So it continues until it goes to the dead end, then afterwards there is nothing to sustain the heat, so it stops. So this is the basic thing. Now what happens is, I made a mistake. Aruna, go to 3 slides, then come back. Go advance for 3 slides. Okay, so this is what it is. And you can see on the bottom is that black one is the sample, that is the compressed tablet or whatever it is. And we applied using tungsten filament, very high current, maybe 50 to 80, I don't remember the current, this one, very high current to initiate, to heat up the surface. Go back now, go back to the 3 slides. 1, 2, 3. Go. Next. Okay. Here we already Here we already triggered the reaction. Almost a thin layer formed. Next, please. So it is the which is glowing is already reacted. You can also observe the applied external current was switched off. So that one is, there is no current flowing through that filament. Next, please. Next. See, you can see almost the filament is lifeless. There's nothing heated up, and the sample is heating. So that's how it is completely done. The reaction takes place. Next, please. So in this case, I just showed, but please switch off ignore glowing of the filament. The reaction is completed, so it remains dark. That means there is no heat. Next, please. So we took molybdenum metal, average about 10 microns or so, later on it there. And silicon, also almost same, and we got molybdenum disilicide particles. Next. So they look like rocks, a little bit of, that means no spherical or whatever it is. But if you do by chemical co-precipitation, most of the time you form very beautiful spheres. Next. So here, silicon, as I said, it's about 11 micron size, molybdenum about 15 microns, and moly disilicide is about 11 microns. In the case of titanium, 11.5, boron to 15.5, carbon is about 11. The titanium diboride we found was 6 microns. Titanium carbide is 5 microns, and boron carbide is 8.5 microns. This is the average particle. In the calculation, we assume a spherical average particle diameter. In fact, but there is a distribution. Next, please. Next, please. So this is how the surface structure, but it is not as clean as what you look. But what happens is once we have taken that pellet, we applied high pressure and reasonable heat, so that hot pressing, so that is how we made it as denser, or else it is really very, very porous. Because once the reaction takes place, all the things come out, that is how, but it is a reduced porosity. Next, please. Next, please. So this is how the particle size distribution, and I showed you the average size. Next. Next. Okay, we did X-ray diffraction. The first one is moly disilicide, and the X-ray pattern of molybdenum and silicon. And by comparing it to the standard of molybdenum disilicide, we can say definitely the reaction was completed, and we got molybdenum disilicide. Next, please. Then what happens is to find out the surface purity. We did this zeta potential measurement by using what is called microelectrophoresis. That means we disperse fine powder and then observe through the microscope how under an applied potential the particles move from positive to negative or negative to the positive. So for a given standard distance, what is the time taken? So as a function of time, distance for time, velocity per current, we will get what is called zeta potential. Molybdenum is called an acidic oxide. Molybdenum is up to pH 12. It only associated with a negative potential. That means completely acidic oxide. Whereas silicon, to certain degree, to start with acidic, but after a pH around 3.5, in this case, it is too much. Actually, it should be less than 2.5 or 2.8. It will show negative. Negative means it is actually a basic oxide. But molybdenum disulfide, it showed the characteristic of molybdenum, and also it actually kind of went back into what is called a negative potential, which is the 0 point is called point of zero charge. So it became a positive oxide, acidic oxide to basic oxide. Next, please. So basically, that graph we can deconvolute, assuming, let us say there is an oxide A, which has a typical curve like that, and oxide B like that. Based on the concentration, the combined effect of both oxides will be either the curve showed as 1, curve showed as 2, or 4, in which case there is a transition, or completely like a curve 6, which will be downstairs. That means which is always negative. So there is, and then because unless there is a group of only chemists, I cannot talk more into this one. It will be boring. Next, please. So this is how we deconvert. And then we have to find out, is it true? To verify what we did, we took the molybdenum disulfide powder and we heated in the furnace. The silicon powder, we heated in oxygen, in air. Then what happens? The zeta potential curves completely behave like a silicon dioxide. So to find out, how do we prove it is silicon dioxide on the surface? Next, please. Next, let us go and okay, next, please. Next slide. Yeah, we have done FTIR. In this one, what we found was based on the time we have done the oxide calcine at 500 degrees centigrade, we can see the formation of what are called silicon dioxide stretching peaks. They suddenly came, which says SiO peaks. So this gave us definitely, it is in molybdenum, it is becoming silicon oxide surface increase. Please. So we did that one, and then completely we have transformed, and based on the temperature at which we oxidized, molybdenum disilicide curve moved towards and became more of a silica SiO2 surface. Next, please. So this tells us definitely this is the oxidation. But the peak, the silicon oxygen peak stretched into two ways. That means there are two types of oxygens associated with the silicon. Is it true? So we did the X-ray photon spectroscopy XPS, on this powder, combustion synthesis silicon dioxide. This is the cumulative curve, and then we generally zoom wherever is of interest. Next, please. People who does this XPS, they are aware of it. So what happens is, this is in a small magnified region, the curve looks like that one. Immediately I can tell there are 3 peaks. And next, please. So this is the curve. Oh, sorry, previous. Aruna, previous curve, please. Okay, in this one, you can see what is called, we use what is called deconvolution. Each peak we do, and then try to fit it. What is the best fit, 95% or 98%? So you can tell there are number of oxides formed. So it is this is a combined curve, XPS, of multiple oxides associated in this one. Next, please. And we found 2 from molybdenum and 2 from silicon, which correspond to that one. Here, basically, SI peaks, 2 are there, definitely. Next, please. Oxygen, there are 2 different oxygen, SiO or SiOO. So it is 2 different, that is what it proves. So the spectrum tells us what we have seen in the FTIR is true, and that supports the change in the zeta potential of the oxidized molybdenum. So with this one, we are really, the justice goes towards a scientist who thinks there are no real non-oxides. Few monolayers, these are all few monolayers. We have done a lot of work. We removed the top layers, and then we don't see all these things. And there's a called Auger spectroscopy. In that one, we actually remove the surface, clean the surface, and we looked at it, nothing happens. So that proves that the oxide formation is true, but for few monolayers, 2 layers. So engineer, out of 10 micron crystal, if it is 0.02%, he doesn't care. It doesn't significantly influence on the final property of the material. So engineer is right, a scientist is correct. Next, please. So this is titanium carbide and titanium boron powders, how their average size. From here, I will go quick because basically I just wanted to show the multiple oxidation system. Next, please. Here, these are any commercial powders are polydispersed. It is not monodispersed, polydispersed powders. And average around 10 and 11. Next, please. Or 12, whatever it is. Next. So this is the titanium diboride and titanium carbide and boron carbide. In the case of boron carbide, they were like a flakes. They look like a mica chips. That is how it is. And these are all fine pebble-like structure. Next, please. So this is a detail of their particle size distribution and all. Whereas this titanium carbides and all, they're smaller, some are bigger. I mean, one has to zoom it and look into that one. Next, please. So when I put it, pure titanium oxide, it will be before pH 5.6, it becomes like a acidic oxide. Above pH 5.6, it looks like, it acts as if it is a base. So that's why TiO2 generally called the amphoteric oxide. Acidic oxide, basic oxide, amphoteric oxide. And the combustion synthesis, TiB2, actually first one looks like a titanium curve, move towards this side. And the other one is a boron. Boron is, first one is boron, boric acid. Second one is titanium dioxide. So the other things is an inversion. So on the left is boron and on the right this curve. And the combined joining is only a combination curve. Next, please. So we did this. This is for the titanium powder and titanium diboride. And then we have boron powder. That is the cumulative curve. Next, please. So what we did the same exercise. We oxidized the titanium diboride. And then we measured the surface electrokinetic property. And the whole thing moved towards just the curve became more of a titanium oxide type of curve. So the whole thing, that means, although we are calling titanium diboride, the material became, for a scientist, a titanium dioxide. That's what it proves here. Next, please. It is only after heating for 2 hours. And we have done another measurement. One company was selling us, so they did for us what is called surface charge distribution. Surface charge distribution curve almost looked like the same thing as titanium diboride. In fact, I wanted to bring, could you go back again, Aruna? Just to go back. Okay, like this one. It was this curve. Next, next. See, this is what it is. The whole curve went up. The trends are the same and everything is the same. Next, please. So this is, what is called, we did what is called viscoelastic response. Viscoelastic response is, it's almost like a spring and power pot. But that means you have a piston, you have a piston and you have a spring. How combination will work? Okay. Sorry. So this is a combination of those things. It also represents the same sort of tendency. Okay, next, please. Again, in the case of titanium diboride, we did XPS. Next, please. So here you can see a combination of 2 titanium oxides, TiO, TiOO, 2, and with boron there is a BO, only 1 oxide. That means total 3 peaks are there within embedded in this curve. And we deconvoluted it. Next, please. So this is what it is. And the same thing in the case of titanium carbide. We hit titanium curve. This is the titanium carbide. Then we oxidized it. It became like this one. Next, please. So this is basically how titanium carbide. And we did the same exercise with the XPS. We proved it. So for a chemist to win his argument, we have to use not only electrokinetic, FTIR, and XPS to tell, yes, there are oxygen in there. So that is what is the next, please. Next, same thing. Next, please. In the case of boron carbide, Boron first peak is around 2.5 because boric acid, it's an acid. Whereas here, with the other transition, there is another one, which is actually more representative of some carboxylic groups. Next, please. Next, please. So again, we did the same exercise, oxidizing, and the whole curve moving downwards, down. So that is basically, we formed the same thing. Next, please. I apologize, I should have switched the whole thing. It is not with me now. XPS, next, please. Here you can see there is one oxygen peak, very nice peak, and one's very shallow peak. And next, please. So you can see that the carbon associated with three different oxides. So these are all being shown here. Next, we have done oxygen peak also. Next, please. So with the oxygen, it says with the carbon, there is one CO bonding, whereas another with the boron CO. So that means in almost, although there are, they said 3 or 4, it is not true. It's only 2 oxygen. 2 types of oxygens are there. That means which is associated with carbon, associated with the boron. Next, please. Okay, here basically, although I should have been a little bit slower, but I came to the last slide of conclusion. All non-oxide ceramic powders contain oxygen oxide layer contamination on the surface. Maximum 2 to 3 mono, at the most 5 monolayers. And then generally a monolayer could be about 5 to 7 angstroms. So 5 means 35 angstroms. So you remove 35 angstroms, nothing will happen. The oxide contamination of these materials depends upon the oxidation state of the constituents. If oxygen splitting is SiO, that means there will be 2 oxygen. Or if it's also molybdenum, then it adds. So you can see all those reflections when you deconvolute the oxygen peaks. The oxide contamination of the surface, why it has not gone too much? Because once the oxide forms, by God's grace, it acts like a passive layer. That means it prevents further oxidation. Same thing, aluminum, we use cooking vessels. Aluminum pans, they look a little bit light whitish color because it on the surface forms aluminum oxide. And we cook in those dishes, aluminum oxide is safe, nothing happens to us. So this is basically the oxidation state. Same thing, silver plates, black silver oxide. It is stable, it perpetuates. So it is good for us. So the moly disulfide as a protective coat. Same thing, the oxide chemistry of titanium diboride, titanium carbide, aluminum nitride. I didn't show aluminum nitrate, so yeah, I didn't remove it here. I'm sorry. And boron carbide, its surface is very complex. But having said that one, they will not interfere in the engineering application of these non-oxide powders. So that is a blessing in disguise. So we use without any fear on all our applications, engineering applications, either coatings or protective layers or whatever it is. We use that one every day. With this one, actually, I should have been a little bit slower. My anxiety, I become a little bit dizzy, so I went in a faster pace. Now everything came subtle. And with this one, I will end my talk. And I want you guys to ask me questions. Maybe I'm talking, I spoke very fast, you didn't understand, so that I can answer you. Please ask questions. With this one, thank you very much. I end my talk.
Thank you so much, sir, for your wonderful talk and explanation also. With a very good slides, very explanatory slides actually. It's time for interaction and having any doubts or any questions to the sir for your futuristic application of this particular talk. I request from the audience side, anybody wish to interact with sir, so as to keep this screen share also. Sir, shall I keep this screen share, sir? If anybody asks, we can rotate the slides. Sir, you are in mute condition, sir.
No, if we want, we can open it, you can close, people
Yes.
can ask and whatever they want.
Yeah, thank you very much. It's a great talk regarding chemistry. Actually, my perspective, my experience in thermal power plant, there is one contamination of coal, the marcosite, FeS2, iron sulfide. It is added with silica. It goes into the boiler during firing. What happens due to the swirling effect of the flame, silica, once it reaches one melting point, it forms on the surface of the water valves, where the boiler water is heated in the water valves. And it becomes a very, very hard material. It's what I could just remember during this talk. So what we used to do is we give a thermal shock. From the outside, we punch cold water on the surface and create a controlled explosion such that it gets dislodged and come down. This is because the heat conductivity is drastically reduced if we don't clean the surface. And if we allow it, layers of this oxide, silicon dioxide, molten material get condensed on this surface, and we have to shut down the boilers for manually chipping it up. This is an excellent talk. This is aluminum oxide. It gets formed. It's not poisonous. Similarly, I would like to ask Dr. Rao. It is a very basic and household doubt. It is those what do you call pan? And pan there will be a ceramic coating. What actually it is? Is it safe? Thank you.
Okay. Okay. The question is very interesting, basically. In fact, I wanted to talk only the coal. Coal has, no two coals are the same. Coal has quite a bit of complex chemistry because we call mineral contamination or ash products. In fact, the lignite coal is one of the poorer coals. So now in this one, not only silica, clay, there is another clay, and also calcium, calcite, that means which comes under calcium carbonate, those things. And another thing is sulfides, iron sulfide. These are all the contaminants associated with the coal. How they remove coal, desulfurization, all those things is done. In fact, I wanted to give a talk on coal today. Basically, the electrokinetic phenomena that itself is complex. I kept that talk for somebody else whom I promised I will give talk on data potentials. So the problem with the coal, with silica, if you burn it, basically what happens, in fact, controlled way you burn it or you heat it above 1,000 degrees and then cool it. Next day you come and see the furnace is full of like spider web. Everything will be mushy and all those things. That is the inherent part of silicon. Silicon dioxide heated up and then cooled down. So the only way they do that one is for silicon thing. During the before the carbonization, they just heat to some extent and wash it thoroughly. So that at that time, washing means it becomes a silicic acid, and it will, most of the things are reduced. And whether they do it, they either successful or bulk the lumps of silicon, I don't know. But it is very efficiently done in the coal slurries. That means coal in a fine powder. Once you have fine powder, the large surface area is, the surface area increases. You understand? So such things you can easily wash off. I mean, that is how I can think of. But a lot of this, this problem is well established and well known to the coal. In fact, coal manufacturers sending for particularly for the steel industry, because for it is more important coal as for the Bessemer converters. So that is what I can, if I understood you right. But you heat it and then wash it, and it will, some of the things are removed. In fact, next time I give a talk, if possible, in that place, you attend on, I talk about 4 different coals. Of course, American coals. One is the Pittsburgh coal, which is very good. But a very bad coal, which is called the Utah coal from Utah, the state of one of the states in which has 18% ash. So the ash is all inorganic oxides. And clay is a peculiar case. It has like a plate structure. On one side it looks like an acid, another side looks like a base. It's very, very interesting. I will talk about it, how we can do. There is another way also we do. The silicon, as you said, in the case of very fine powders, I mean, slurries, what we do, we bring the silicon by adding some surface active agents. That means you can modify the surface. Just a small, less than 1.8%. If you add that one, then what happens? This whole surface charge becomes 0. You remember I showed a curve for every given oxide, there is a time when there is no potential. So they make it. When they make it, that settles down because it has no charge. So it settles down. So centrifuge, they remove it. So that is how it is done. But in a large power plant, as I said, in a power plant, these things I don't know because I'm not aware of it. I'm only a basic scientist.
No, sir, what you told is correct. Actually, lignite is having only 5 to 7% ash. Bituminous coal, once it comes out of the coal mines, we add percentage to an extent of 40%. That is why it goes for the washeries. That is actually for 2 purposes. One is to remove the ash, another is to reduce the transport cost. Thank you.
Sir, you are in mute conditions.
You registered for this course, so you should ask, you should demand. So don't be shy. There is no question that is silly. At the same time, there is no question that is very complex. So it is a test for me. I am attending every time I give a talk, attending for an exam. So please use the opportunity, come out and ask and clarify whether it is simple, or you may think it is simple, or it could be complex to me.
Anybody else from the gathering? I request Sadhana ma'am. Guljit ma'am.
Hello,
Yes.
Ma'am.
Gurjeet, Dr.
Yes.
Gurjeet.
Yes, please,
Okay.
ma'am.
Can you please repeat?
Repeat
Yes,
what?
ma'am. If you like any questions or any interaction with sir regarding this talk, we are announcing. Yes,
Yeah,
we are-
I'm making some points. If then I'll discuss with the sir after this lecture. After
Yes,
completion of this lecture.
Yes, ma'am. Yes, ma'am. Already session completed, and this is the discussion time, ma'am. Now you
Okay,
can ask. Now you can ask to sir, ma'am.
Okay, sir. Yes.
Am I audible, madam?
Yes, ma'am.
Yes. Yes.
Madam, can I ask a doubt, query?
Yeah,
Yes, ma'am.
please.
Okay. Sir, hello, sir. Professor Srinivas Rao, sir. Am I audible?
Yes. Go ahead.
Yes.
Mm.
So I have this doubt regarding the ceramics details that you gave. So what are the key advantages of this non-oxide ceramics over oxide ceramics? Basically in terms of thermal and mechanical properties. Could you please
Okay.
help me out, sir?
Sure. It's a very good question. As the non-oxides, they can sustain high temperatures. They will not lose their mechanical strength. Whereas oxide ceramics accepts certain things like zirconium dioxide, other sort of things. They will not sustain the same sort of vigorous and also corrosive environment. So those are the advantages. So these are typically non-oxides are classified as high temperature materials. Okay.
Okay, sir. Thank you, sir. One more question can I ask?
Sure. This is discussion time.
Okay. Sir, yes, sir. So you have listed out different synthesis methods. So among these methods, which technique do you refer? Like, do you suggest is the best with respect to balance between cost effectiveness and high purity?
Can you please slowly ask me questions,
Okay.
because I cannot
Sure,
hear.
sir. I will repeat the question. Sir,
Yeah.
you have listed out n number of methods. Among the methods, which method do you recommend as the best balance between cost effectiveness and high purity in the non-oxide ceramics?
Okay. In that one, ceramics means a whole series of things are there. If it is oxide ceramics, people go with what is called co-precipitation method or hydrothermal method. And in this one, co-precipitation method, you can get a uniform spherical particles. It has an advantage, disadvantage. The advantage is you can have very narrow size distribution, and the smaller particles can be produced. That means we are talking about maybe 10 nanometer per size, 10 to 20 nanometer size. But when you try to sinter them, sinter means fuse them together, there are more number of surfaces, contact surface has to be fused. And that is, it requires more energy. And I am not a proponent of this nanotechnology. Nanoscience is only by coatings and all. But to make a monolith, it is much difficult. In fact, even electronic ceramics, I have done a lot of work. The smaller the particle size, it is a nuisance. Whereas in the strength case, zirconia toughened alumina, I did a lot of work on it. The smaller size will not help the strength, regain the strength of the sintered material. So that is the disadvantage. Next, another thing is homogeneous. If you try to mix powders, you can never mix two powders in dry state because homogenization is very, very difficult. If you guys recommend next time, I may talk about the powder synthesis, powder processing from what is the advantage from dry powders or the co-precipitation type of thing, filtration and all. That itself is completely different. In case of non-oxides, the diffusion bonded, that's another thing. So there are advantages, and it is the material specific for application. You cannot use everything, a single recipe for all the ceramics. So that is why if it is aluminum based, titanium based, these things can be done. I developed another thing called what is called a powder atomization. So that means you take fine dispersion, fine powders, and at a very high speeds, you atomize into the precipitating medium. Then what happens is the surface coating crystallizes as a fine crystallites. And then you can effectively have a uniform distribution. Maybe sometime if I give a talk on aluminum oxides, aluminum titanium oxides, I can tell. And you can see those things. So it is everything is a specific subject. You cannot tell a single recipe for those things. So sometimes what happens, I developed an instrumentation also for gelation. Generally, sol gel process is one technique, but generally sol gel process ends up after sintering a porous material. So, instead of that one, what I did was, again, the spray atomization and formed the gel in a crystal, fine crystal, not spheres, spheroids, small spheres, and then try to do that one. Again, the same sort of thing. You have to make a balance between your application, what you need, and how you can ascertain it. It's a very interesting and very important question you asked. It is really, really important. Okay? Yeah, anything else? Yeah. Any further clarification? I'd be more than
No,
happy
sir.
to.
Clear. Thank you so much, sir, for that
Okay.
wonderful clarification and that wonderful session. Thank you once again. A lot of gratitude to you, sir. Thank you so much, sir.
Good.
Thank you, ma'am, for your
Then
utmost
the-
introduction, actually.
Anybody
Thank you,
else?
Anybody else? Ma'am, Guljit
I
ma'am,
have one question, sir.
Sure.
please ma'am.
Yes, sir, I want to know something more about XPS studies, sir, because we are aware of FTIR, but we are less knowledge about XPS. And also, I want to know why the specific size is 10 nanometers.
Say that again.
Sir, you are specifying about the titanic diboride that is 10 micrometers, sir.
Okay.
So why you have chosen that size that I
Why
that
I
also
chose,
want to know.
why I chose, okay, why I chose means my, it may not be 10 micron. I think diboride, I have shown the particle size, maybe 6 or 8. The reason I chose that one is those are the things which we synthesized. We didn't manipulate anything else. These are as synthesized powders we analyzed. So it is no other specific requirement.
Okay, sir. Then I want to know something more about the XPS study, sir.
Okay, sure. XPS studies, as we have done the powders, those are the ones which we analyzed it. And also the XPS, we analyze those powders which we further oxidized. So these are all the powders which we have done as synthesized as processed. So there is nothing we have changed or we manipulated. We just put it on an XPS tub and then we analyzed in the instrument. Okay? You know that.
Okay, sir. For oxidation study, this XPS study they are doing, sir.
Yeah.
Okay, sir. Okay, sir.
Or else there is a variation. What you did, we just put it in. That's it. And for the electrokinetics, we need a few particles. Yeah, a zeta potential. Just to smear it, that's all.
Okay, sir. Thank you, sir.
Okay. Anybody else?
I request anybody else to interact with sir with your questions or doubts.
Because or else we will end up closing session at today's session before time.
Adi Sharma ma'am.
Namaste, sir.
Oh, okay. Any questions, please?
Sir, I want to ask, what are the other utilities of this?
Utilities of what?
Like this material, oxide material, which is used in high temperatures.
Okay. Non-oxide
Non-oxides, yes, sir, non-oxide materials.
Actually, there are many different applications. Say silicon nitride. If it is silicon nitride, if I knew, I should have shown some of those mementos I got. They are going to be used in the future. At one time, they considered it as a turbocharger, the motor cars for turbochargers. So that means the engine operates almost around 1700 degrees centigrade. So that means you can have more power. So, and also some of those things where corrosion is a problem, these things can be used, components. So, so like that one, mostly for aerospace application. Oh yes, I forgot. These non-oxides, particularly coatings, are very useful as implant applications. Like a lot of times it's the joints, hip joints. So they will have the cup and cone. What they do, they they cover few monolayers on the surface of this cup and cone, and they used in the prosthesis. So these are biomedical applications out there. So everyone, wherever non-oxide ceramics, so these are the potential applications, structural applications, electronic applications. I have not gone into the dielectric materials and all those things. Those are also there, some of the applications. Okay?
Thank you, sir.
Okay.
Thank you, sir.
Thank you, ma'am. Thank you so much for your interest and joining with us, ma'am. I request anybody else. Dr. Vidhi Grover, ma'am. Sadhana, ma'am. Arvind, sir. Gurjit, ma'am.
Ma'am, I have one more question.
Yes,
Sure.
ma'am.
Sir, can we use these non-oxides for coating ships as they corrode much faster? Can we use them there?
For ships, in the case of it can be used, but I don't know. But maybe in the propulsor applications and all. But for hulls and all, okay. Now, from the defense point of view, some I can tell, some I can't. These materials are really used for taking the impact of the shells. That I'm just looking for the word. They put the coating on the surface. So in fact, boron nitride, boron carbide, they could be used on the tanks to cover. So they
I
can
see,
take
sir.
it down and then they can absorb the impact energy very efficiently. And the exact wording, it's in my mouth, I can see, but I'm not able to tell. So these are used for those things. But for the ships and all, no, I have not come across, because the reason is I can't comment on it.
Sir, as
That-
your last presentation was on corrosion on ships, so from there I got this idea that such materials can be used to prevent corrosions and all that.
Well, the problem is one thing. For the ships and all, the limitation of ceramic, either coating or ceramics, is they cannot be formed very easily. Let us say you have a steel plate. Let us assume you coated with ceramic coating. That is good. Like welding is a limitation. You can't weld easily.
Yes, sir.
So you may
Sure.
say, on the welded body, I can coat it. No, a ship. In fact, for sometimes a question, I will answer with a question. When I I joined the Navy lab, I used to think, well, we can do high temperatures, than superconductors and all those things. What we do in the labs may be small pellet, superconducting yttrium, barium, copper oxide. But when I went there and saw the ship engine, some of the cables are about 2 to 3 inches in diameter. So will I be able to practically make a superconducting cable of what length? So in the case of naval vehicles, for the whole structures, it's not practical.
Possible. Okay, sir.
That is the
Thank you, sir.
limited. I will tell you the another way also. There is, we can make glass out of steel. In fact, I preferred today's talk as glassy steels, modeling of glassy steels. Then I thought it could be, I had to talk more of theoretical work, so I didn't. So when you make glass, it was really very strong. Glass is very, very strong. So what was the purpose? At one time, the scientists thought, keep all these nuclear waste inside the container made out of glass, steel container out of glass, and bury in the ground. That is fine. But what happens if you want to attach something? You just weld the parts. When you are welding, it crystallizes, so whole thing goes bad. So there are a lot of associated auxiliary problems with these materials, with the ceramic material. Glass is also part of ceramics.
Yes, sir.
So the process is complex. Okay.
Thank you very much, sir.
Okay. So I think maybe 1 or 2 questions, then we can close it, I think. Aruna, you have any question?
Yes, sir. Actually, whatever ma'am, Rajshri ma'am and Madhu Sharma ma'am asked you, that only I wish to ask you. And regarding application orientation, sir, mainly.
Yeah, sure. The application, I told you, everything has a limitation because the formability, that means if it is a metal, you can easily turn, you can cut it, you can do. Whereas here, to make a shape, it's a little bit difficult. And so that limits the ceramics.
One more, it may be small, but I got small doubt, sir.
So
That is boron carbide. Can we write it as B4C3, sir, or only B4C we can write, sir?
B4C, boron carbide. B4C. Mm. There is
Namaskar,
another.
sir.
Okay, go ahead. Anybody?
Sir, Namaskar, sir.
Yeah.
Sir, these ceramic materials are brittle in nature.
Yes.
So their brittleness is useful for us, or we should try to make them robust and sturdy?
Can you slowly ask
Okay,
me
okay,
the
sir.
question?
These materials are brittle in nature.
Yes.
Is their brittleness useful for us for the applications, or we should try to make them robust or sturdy
Well,
material?
okay. Brittle materials are very hard. The hardest materials are brittleness. The strength is very high.
Okay, sir.
The only problem of the brittleness is they cannot absorb shock. See, sometimes you drop a glass, it falls on the ground, nothing happens. But you drop a glass, first time it goes up and falls, then breaks. The reason is it was not able to take the shock, secondary shock. So that is the problem with the brittle material. So, so the forming problem is there. That's why most of the ceramics, you make a fab, we call prefabricated material, and you sinter it so that you will get a final product. So that is only the problem. But brittleness has wonderful strength. So metals have nowhere near ceramic hardness. Metals, because malleability and ductility is there in the metals. Say for example, even nickel alumina, it's a very high strength, but the forming is difficult. So the moment you make a system rigid, the secondary effect is what we have to be concerned about.
Strength will be less than. Yes. Thank you, sir.
You're welcome. So
Thank you.
any last question? Then we can.
Anybody else?
Nagababu Abarazu, maybe he has any question? Because he has not heard, so you don't have any. Okay, I think it's enough. Maybe you can say a few words before closing the session. And tomorrow it starts at 7:30. You just tell everybody what it is tomorrow's time.
Yes, sir. Tomorrow also we can have this. If it is possible to everybody, we can start at 7 o'clock, sir. 7 to 8, and 8 to 8:30 will be the interaction, so that we can close before 9 o'clock to make all the people to be convenient. I'll be informing all through WhatsApp and mails also regarding the timings again for day 2 also. Sir, you are in mute conditions.
Okay. Please also tell your next award ceremony and what your plans, how you are visualizing what it is, and what are the pros and cons of having a memento and what it is. Just to find out the ideas, because a lot of people may not recognize the importance of it.
Actually, as usual, every year the Siddhi Foundation is going to organize Guru Pratibha Puraskar, sir, since 2022 to till now. And one hybrid mode, one session we had organized in hybrid mode, sir, in 2023. And 2024 also we had organized online. And again, on the eve of birth anniversary of Dr. Sarvepalli Radhakrishnan Bharataratna, we organize, Siddhi Foundation organizes Teachers' Day celebrations as Guru Pratibha Puraskar, sir, GPP. And that we had planned on September 5th. That is also, I'm planning to conduct in online in the evening sessions only, evening time only, to make convenience of all the working people and from foreigners like you also, sir, who are staying outside of India. So to make convenient timings to all of them, we are planning to organize that award ceremony mostly in the evening time after 6 o'clock, 6 p.m. in India time, sir. And regarding that, we had already finalized the brochure also. All the academia and researchers also can apply, and the Siddhi's highest award also can be announced as Lifetime Achievement Award in that particular this thing, sir. And all the award categories also have been given in the brochure, and which will be forwarded to all the participants whomever here we are having some separate group, and I'll be posting in that group, sir, at the end of the day of this 7-day lecture series. And one more opportunity Siddhi Foundation got to collaborate with one college, government arts and science college from Maharashtra, and we are about to organize one conference, international conference, most probably on 24th and 25th of September. So in the very near future, coming month, we had planned 2 events. One is exclusively award ceremony, and another one is exclusively international conference. This is the short-term goal of as of now for the Siddhi Foundation. And as usual, Siddhi Foundation organizes Sardar Vallabhbhai Patel's birth anniversary also in the month of October. That is on 28th of October, and we are about to organize 2 days, 27th and 28th, on the eve of National Ekta Divas, Rashtriya Ekta Divas. So these 3 are in pipeline as of now, and those who are interested, they can apply and they can nominate, self-nominate for the awards, and they can present their papers in the upcoming events also, which will be given very soon in our website also. Already GPP we had put in our website, sir, and one more brochure we are about to put in our website. And we can give one more opportunity to all these 7-day lecture series participants to send their papers to our ISASCM also, which is a double peer reviewed journal, and which got ISSN number also. You can, all the participants, you can view our website, have format of our papers also, and those who are interested, they can send the papers for the publication, and you can contact me directly for the publication opportunity also. These are the things Siddhi Foundation is planning in the coming near future. And those who are applying, nominating their self-nominations to this GPP, Guru Pratibha Puraskar, Siddhi Foundation is giving as a complimentary the life membership also. Along with the award, we are about to give life membership also. There is no need of applying additionally life membership. These are the things.
Well, I think this is a very good news to me, and very good opportunity for you guys. I personally feel those there is nothing called a small award or a big award, but it is all these 7-day speakers, they are all mostly either qualified to be a distinguished in their field or a lifetime achievement level people. So therefore, I personally feel and support and encourage them to show interest or getting an award as well as memento. And this one is really a standalone, and as I remember, these are custom-made awards, award mementos. I thought one. Okay, I see. So please consider them, and of course it's a Indian participants. It will cost them 5,000 rupees or so, but it is not the question of it. It includes your shipping as well as the custom-made award. So please consider that. And in fact, Siddhi doesn't make any money on these awards. Please don't. All conferences, they will go under registration fees. Here, the registration fees is a very small amount. So with that one and the privilege I had, I just said this one. I'm representing the audience. That's how I said that. So almost all these speakers use their opportunity, and others also apply if you have somebody in mind, for them also you can apply for the awards, or just give them, and Sidvi will be happy to consider. Okay, thank you. And today, today it was my first lecture, and I was in the morning, I was shaking with dizziness, and thank God I was able to deliver whatever little I know. I'm sure you guys have enjoyed it. And tomorrow will be a talk by Mr. Surya Narayana on how thermal plant and the management perspective of the operation of thermal power plants in India. With that one, I I say goodbye. And anybody else have to anything to say just at the end? Nothing to do with the subject. Anything you guys can ask questions. You can ask Aruna before we close today.
Yes, sir. I request anyone from the participant side, one more chance we got to interact with Professor Srinivas Rao sir. If anybody interested, anybody wish to interact or anybody wish to ask anything?
No, I didn't mean that one. I said from the audience, anybody has any question or any suggestion, any comment, that's what I'm asking. Subject-wise, it is, I think you guys had enough.
So tomorrow, my talk will be on thermal power plant project management, and mostly of the intricacies involved in managing systems. It's not on any technical matter, so everybody can follow it. What are all the different accidents that had occurred, and my personal interaction with Dr. APJ Abdul Kalam during my interaction in thermal power plant, and my experiences of some of the accidents that had occurred at Rajasthan plant construction, and managerial intricacies involved in it will be more prominent in the talk, such that everybody can just follow. Is construction of any industry, what are all the difficulties that come in the way? So you can join all of you and share your views. Thank you. Thank you, madam.
Yes, sir. Thank you so much, sir, Suryanarayan sir, for accepting our invitation as a speaker. And we are about to have your speech by tomorrow, 7 p.m. sir. 7 p.m. sharp. We'll start your session, sir, tomorrow.
Okay.
Now, I request any one or two members, please give your feedback of today's session and this lecture series, or any suggestions also, not only feedback. You can give any suggestions also, any modifications if we need to do, because this is the starting today only. So still we have to travel 6 more days. So any suggestions from your end, any modifications we need to do, or any feedback? I request any one of the participants, please give your valuable feedback.
Am I audible, madam?
Yes, ma'am.
Madam, I would like to congratulate you for this wonderful initiative. In fact, most of the participants here, they agree with me, because it's such a great initiative, and we feel so encouraged and we feel so motivated, especially by your words and our Professor Srinivas Rao sir's motivational words. I thank you once again with my heartfelt gratitude, and keep doing the great work, madam. You are so motivational to all of us. Thank you so much, madam, for being there with us. Thank you so much.
Thank you, ma'am. Thank you so much. It's not only possible with me only. It's the cooperation from all. Without you, I'm nothing. Without all the cooperation, I'm nothing. Thank you so much.
It's a great work, madam. Congratulations for that. Thank you, madam.
Any suggestions? We request any suggestions from the audience side. Okay. That's all, sir. With your permission, we can close the today's session, sir. Thank you so much, and I request you to please be with us since all these 7 days, sir. Already 1 day over with your great talk, and I hope and I request you to please join with us for the remaining sessions also, sir. I pray God always give you more strength and health, because you need to explore many budding researchers and budding teachers. Thank you so much, sir. Thank you.
We will have national anthem every day. I think that is good idea. We will conclude with national anthem. Okay.
Obviously.
Yeah, everybody stand and then we will have
Yes.
that.
I request everybody please stand before your laptops or mobiles, whatever it may be, to join your tone for singing national anthem. जनगणमन अधिनायक जय हे भारत
भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा
ग्रामीण उत्कल
वंगा
विंध्य हिमाचल गंगा जल जल तव शुभ में गावी तव शुभ शिरमामी
जय हे भारत भाग्य विधाता
जय
जय हे जय हे
जय हिंद.
Thank you.
Thank you, sir. Thank you so much. And officially, I'm announcing that today's session over, and tomorrow's session will start from sharp 7 o'clock, and the meeting will be open from 6:30 onwards, 6:30 p.m. onwards.
Thank you.
Thank you. Thank you so much.
Thank you, madam.
Thank you, ma'am.
Thank you, ma'am. Thank you so much.